Hey class, I thought I'd make a video to help you guys get started on numbers 7, 8, and 9 on the homework, just because they're a little tricky and they require a little bit of a math trick. At first glance it seems like it's going to be really quite complicated. You have to try to figure out density and other things, but I'm going to show you a trick that's going to make it a little bit easier. Okay, so what we have here is we have a situation where we have some sort of container, maybe a scuba tank or something. We're going to fill it up with air. That is 300 Kelvin is the temperature. Alright, and we heat it to 600 K, asking what the new temperature becomes, and we're assuming that we're filling it at atmospheric pressure, so that its initial pressure is 1,000 pascals here. 100,000, pascals. So, how do we go about figuring out what the new pressure is going to be when we heat it up? Well, one way to do that is to first consider, recall, density is equal to the number of particles, the particle density at least, which is what we're using here, over the volume. So, if you have a set container, the number of particles, and it's sealed, the number of particles and the volume, neither of those are going to change. So we can observe that our density is going to be constant. K is also a constant, so these two values are not actually changing at all. So what I want to do is I want to actually take this, equation here, and I'm going to divide both sides by t, and you'll see why shortly. If I divide both sides by t, the t cancels, this t canceled, and what we find is that we have pressure divided by temperature is equal to K times density. Well, K times density, we just said, is a constant, right? These things are not changing no matter what, constant. So what that means then is that P over T is going to be equal to the same value, whether it's 300 Kelvin and 100 pascals or 600 Kelvin and some other pressure. That division of pressure divided by temperature will always be a constant value. So what we can do is we can rewrite an equation for this situation that tells us any pressure P1 over any temperature T1 will be equal to any other pressure P2 at its new temperature T2, assuming you have constant density. And so this here is the equation you can use to try to solve this problem. Because if we look through this problem statement, we can extract some of these values, right? We can find P1 is 100,000 pascals, T1 is 300 Kelvin, and T2 is 600 Kelvin, and P2 is what we want, question mark. So anyway, you can use that equation to try to solve. Pretty cool, right? In number 8, it's actually a very similar situation, but there's a slight difference. Alright, so here we're told that we have an air compressor. It's going to pump air particles into a tank. So again, maybe it's the device used to fill up a scuba tank or something like that. Alright, and so we're told that it adds air particles into the tank until the particle density inside is 60 times what it is outside. So 60 times more than what it would have been normally. Alright, so as a result of pumping this air inside, there's a change in the pressure, and so we need to look at how we can determine this new pressure that is induced. But it's different here, right? So in this case, if we go and label our variables like we did before, we know that the pressure that would start, the outside pressure, is 100,000 pascals. Alright, the new pressure is what we're trying to figure out. What would its pressure be inside the tank? And we're told, right, that the temperature, we give it some time and the temperature will be equal to the same value. So temperature is a constant, just like we had density a constant in the previous problem. And we're told that density that we start with is 1 times what it is later, and the density 2 that it is later is 40 times that initial value. So we're not actually given a value for 1 or 40. 1 what? 1 atmosphere, 1 pascal. It's not going to be 1 pascal, so 1 something. So you can make up any units you wanted to. You could say 1x, you could say 1 dog, you could say 1 cat, you could say 1 whatever. Create your own units. I'm just going to say 1x and 40x. Okay, so x is just some arbitrary value. So if we go through the same process that we did last time, starting with our original equation, pressure equals K times density multiplied by temperature, if we divide both sides by the density, we should get that pressure divided by density equals KT, where again, KT here is a constant. So what we can find is that we can use an expression that P1 divided by density 1 is going to be equal to P pressure 2 divided by density 2, and again you can plug in the values we're given and use that to solve. So we're rocking and rolling here, pretty good. Now I just want to talk briefly about this very last problem here, okay? So the last one's a little bit different. In this one we're asked how much force air is exerting on a book. So I did the demonstration in class yesterday where we saw a soda can be crushed by atmospheric pressure simply by reducing the pressure of the air on the inside of the can. So atmospheric air had so much force exerted on that can that it is able to completely crush the can. Pretty wild. So in this case, we're asking at normal atmospheric pressure of approximately 100,000 pascals, how much force is being exerted on just a book sitting on your table? How much force is that air pushing down with on top of that book? So if you remember, pressure, we learned this in class yesterday, pressure is equal to force divided by surface area, right? So we're asked to find force in this case, so to find force, we multiply both sides by surface area. Force is equal to pressure multiplied by surface area. Okay, so what is the pressure and what is the surface area? Well, pressure, we're given that's 100,000 pascals. Okay, surface area, that is just the surface area of the book, which, since we're given its length and width, would just be length multiplied by width, but we want meters, right? Units for pascals are based on square meters, newtons per square meter, so we need meters. So our surface area would be equal to, take the length, 15 centimeters is 0.15 meters, and multiply it by the width, 0.30 meters, and that would give you your surface area. So whatever that equals is your surface area, and then you can solve for the force by taking pressure times surface area. So anyway, that should get you started. I'm not giving you the solutions completely, just the process of how to get there. I hope that helps. Let me know if you have any questions.